Antenna parameters. Important antenna parameters as followings: radiation resistance, antenna efficiency, antenna directive gain and power gain, effective isotropic radiated power, antenna polarization and radiation pattern, antenna beam width and bandwidth, antenna input impedance and antenna matching. Radiation resistance. Radiation resistance is the resistive part of an antenna's feed point impedance that is created solely by radiation from the antenna, where V equals P rad divided by I with the power of 2. Antenna efficiency. Antenna efficiency is the ratio of the radiated power by an antenna to the total input power. The total input power is the sum of power radiated by the antenna and the power dissipated in the antenna, in the form of heat. Antenna efficiency also can be related to radiation resistance, where it is the ratio of the radiation resistance to the total resistance, where antenna efficiency equals P rad divided by P and or RR divided by RR plus RE. Antenna directive gain. Directive gain of antenna is the ratio of power density radiated in a certain direction to the power density radiated by a reference antenna to the same point, assuming the input power for both antennas are the same. An antenna does not amplify the input power, it just concentrates its radiated power in a particular direction, where D equals PD max divided by PISO. Power gain. Power gain is the same as directive gain, but the antenna efficiency is taken into consideration. G equals antenna efficiency multiplied by D, or, in decibel. G, decibel, equals 10 log 10, antenna efficiency multiplied by D. If the antenna is lossless, it radiates 100% of the input power, that is, G equals D. To obtain a maximum captured power, a receiving antenna is best positioned in the direction of maximum radiation of the transmitting antenna. Effective isotropic radiated power. Effective isotropic radiated power, EIRP, is the measured radiated power of an antenna in a specific direction. It is the output power when a signal is concentrated into a smaller area by the antenna. The EIRP can take into account the losses in transmission lines and connectors and includes the gain of the antenna. It is represented in decibel. Power density. Power density is a measure of radiated electromagnetic power per unit area at a distance r from a transmitting antenna, where equals P and multiplied by G over 4 pi r squared, or P rad multiplied by G over 4 pi r squared. This is the antenna parameters. Next is the antenna polarization. Antenna polarization is the orientation of the electric field radiated from it. There are 3 types of antenna polarization, which is linear polarization, where horizontal is usually used for higher frequency antennas, since most man-made noise has vertical polarization, and vertical is usually used by lower frequency antennas because of the proximity to the ground. The second one is circular polarization. And lastly, elliptical polarization. Radiation pattern. A radiation pattern is a polar diagram representing field strength or power densities at various positions relative to an antenna, made up of 4 lobes: major lobe, back lobe, and 2 side lobes. The major lobe is the radiation lobe containing the direction of maximum radiation. The major lobe propagates and receives the most energy. The back lobe is the radiation lobe whose axis is 180 degrees with respect to the major lobe. The 2 side lobes are the largest minor lobes. Minor lobes are lobes that are other than major lobes, normally represented undesired radiation or reception. The front to back ratio is the ratio of the front lobe power to the back lobe power. The front to side ratio is the ratio of the front lobe to the side lobe. The line of shoot is the line pointing from the center of the antenna in the direction of maximum radiation. Antenna beam width. Antenna beam width is the angular separation between the 2 half power, -3 decibels, points, or when the power drops by 3 decibels on the major lobe, and B. It is called negative 3 decibels beam width or half power beam width. The typical value is between 30 degree to 60 degree. Antenna gain is inversely proportional to its beam width. The higher the gain of the antenna, the narrower is the beam width. Antenna bandwidth. Antenna bandwidth is the frequency range over which operation is satisfactory, which is equal to the difference between the frequencies at which the received power falls to 1/2 of the maximum power, in the direction of maximum radiation. Antenna input impedance. The point on the antenna where the transmission line is connected is called the antenna input terminal or the feed point. The feed point presents an AC load to the transmission line. It is called the antenna input impedance. Antenna matching. When the antenna input impedance is equal to the characteristic impedance of the transmission line, they are matched. So, there will be no signal reflected back, and maximum power will be transferred to the antenna. Resonant antenna. For the non-resonant antenna, the input impedance will have a reactance component. Zn equals R plus Jx, if the feed point is at a current maximum and there is no reactive component. Antenna design and simulation. Antenna design work can be done by using modeling software that analyzes their antenna parameters. The M-Full Wave simulators used in this work is CST Microwave Studio. Click here to watch the antenna design and simulation tutorial.